In this lecture, we're going to finally allow our air transport to unload those units that have been loaded inside of it. What does that look like? Well, when a player requests to unload a unit, we want to navmesh sample position at the current position. If this fails, the unit cannot be unloaded. Then we want to unparent and re-enable the game object. Then call navmeshagent.warp to update the navigation system that this navmesh agent has moved outside of its control and it needs to start considering it from this new position. None of what we just talked about requires a change to this behavior tree because it's something that happens right as the player clicks and shouldn't really change the behavior of this unit. Since we need the player to click a button on the UI, we need a new command. Let's come over to VS Code and in the scripts commands folder, let's just copy our load unit command. It's going to be kind of similar to that and rename it to unload all units command. Let's open that up. Change the class name to unload all units command. Change our create asset menu, file name, unload units, menu name, units, commands, unload all units. And let's set the order to 107. Now for can handle, we really only need to know that it is an iTransporter and that transporter used capacity is greater than 0. Then on handle, we don't really need the transportable. We can remove the line about getting the transportable and just change the load to unload all. And for isLocked, let's just convert that to an expression bodied function for false for the time being. Now we've got that command, we'll be able to assign that to the air transport in just a minute, but we need to implement this unload all. That's a little bit of a challenge because we don't actually keep track of the units that are loaded. We've been keeping track of the targets that we want to load, but when we do load a unit, we're not keeping track of them. So up at the top, let's make a private list of iTransportables called loaded units and set that to be a new list with a default capacity of 8. Then for get loaded units, we can just convert that to an expression bodied function to loadedunits.toList. Now, if we come down to handle load unit, right after we increase our used capacity, we can just add this to our list with loadedunits.add transportable. Now we're keeping track of them. And for unload all, we can iterate backwards over our list of loaded units with for int I equals loadedunits.count -1, I greater than equal to 0, I minus minus. And we want to go backwards because we're going to be removing items from this list, which means if we were to go forward, we would end up skipping some. So if we start at the end and go backwards, it works a lot better. And here we can just do unload loaded units indexed by I, and at the bottom just return true. But we still don't have unload. So in unload, we said we wanted to do a navmesh sample position. To do that, we need to know the navmesh query filter for this unit so we can determine if we can place this unit. So let's define a navmesh query filter. Query filter equals a new navmesh query filter. And this has two properties, an area mask and an agent type ID. We want to populate both of these from the unit, but the iTransportable doesn't expose a navmesh agent. So the simplest way to handle this is to add it to the iTransportable. On iTransportable, let's define a public navmesh agent with a public get. Now this will break our base military unit because it doesn't have the agent. On the abstract unit, we have a private navmesh agent. Let's just convert that to public, add the public get and a private set, and then rename it to capital agent. Make sure you do the rename symbol so it updates all of the references. Once we've done that, we can come back to the air transport and assign the area mask to the unit.agent.areaMask and the agent type ID to unit.agent.agentTypeID. Now the rest of this is this lecture's challenge. Complete the unload function so it only allows unloading units on pathable areas for that unit. Return whether or not the unit can be placed, and if it can't, don't unload it. So pause the video, implement this unload function, and I'll see you back here in a few minutes. All right, welcome back. We just need to check if navmesh sample position from the transform position, providing out a navmesh hit. I'm using a radius of 1. We can play with this value if that doesn't work out very well, and providing the query filter. Then in here, we want to do used capacity minus equals the unit transport capacity usage. Unit transform set parent null to unparent it from this air transport. Unit transform position equals the hit position. We can then enable the game object with unit transform game object set active true, and do unit.agent.warp to the hit position. Then loaded units.remove that unit. And in this case, we want to return true. And if we didn't come in here, we'll just return false. That's all we were looking for in this challenge. We went through the high-level steps at the beginning of this lecture, so I hope you're able to do this one on your own. If you ran into some problems and they're the ones we're about to see, that's totally fine. This does not work quite properly, so I know I have a little tricky challenge for you. You can just test this, but don't worry, we're going to correct it in just a minute. Let's come back to Unity. In the Units Commands folder, let's go Assets, Create, Units, Commands, Unload All Units. We'll name it Unload All Units. Give it the name, Unload Units. For the icon, let's do the down arrow. The slot should be 7, and this does not require click to activate. Come over to the Air Transport Prefab. Let's go ahead and give them that command. Click plus under Available Commands, and change the last one to Unload All Units. Let's go ahead and come up to the top, Overrides, Apply All, and let's go ahead and click play. Take both of these units, send them in to get loaded. Click on the Air Transport and Unload All. Oh no, why don't they unload? Let's go ahead and pause. Come over to the scene view, select our floor, come to the AI navigation, surfaces, show nav mesh. So here's the problem. The air transport is floating quite a ways above the ground unit's nav mesh. Remember, we did this to allow it to path over buildings. We create an empty game object and attach a sphere collider. With a radius of 1, we can see why that nav mesh sample position did not give us a result. And while we could do something like increase the radius to something like 2, the larger radius we give nav mesh sample position, the slower it gets, and the more likely we are to choose an unexpected location. So let's leave play mode. How do you think we can keep a small sample position radius while still making sure that we hit the right nav mesh? Let's come back to VS Code. Instead of just sampling a position, if we also perform a raycast down from the current position, that'll find us a spot on the floor. And we know the air transport is always going to be floating above the other nav meshes. This will give us a more accurate initial sampling position. So just before we do the sample position, we'll do a raycast. I'll just move this down to a new line and add an and before it. So we can raycast starting from the transform position, going vector 3 down, provide out a raycast hit, and we can use float.maxValue. It's not really important what the value here is. And then we need a layer mask. And while the easy solution may be just attach it to the air transport, this is really a transport config type of thing. So if we come to our transport config, let's attach a field serialized field, add a public layer mask, safe drop layers with public get and a private set. Then back on the air transport where we're doing the raycast, we can add in the unit SO transport config safe drop layers as the layer mask. This is now too long for one line, so we can break up that raycast into multiple lines so we can actually read it all on one screen. Then instead of doing nav mesh sample position from the transform position, we can sample position from the raycast hit point. Now let's come back to Unity, and in the project panel, units air transport, let's select that air transport config and set up the safe drop layers to be the floor. Then we can click play and we'd expect that this works. Let's select the units, send them into the air transport, and click unload, and there they go. They're both dropped. Now if we move the air transport, we see a problem. The units are still trying to follow it. That's not what we would expect to happen. Let's come back to VS Code. There's one last thing that we can do. In unload, after we've warped the agent, let's check if the unit is movable, and then just give them the command to move to the nav mesh hit position. Let's come back to Unity for one last time, click play, reload those units, unload them again, and the air transport can move away without these two trying to move to it. Great. We can spend some time polishing off the unload behavior to add some delay by unloading them in a coroutine and all kinds of stuff there. But now we have the fundamentals of loading and unloading, and it's working. That's all we've got time for in this lecture. When you're ready to move on, I'll see you on the next one.